The frequency response of a line array, specifically the balance between lower and higher frequencies, is determined by the number of loudspeakers in the array and their splay angles. For simplicity, let's assume that this array of 4 loudspeakers has a more or less flat overall frequency response. Let's assume further that flat is the desired target response. Adding loudspeakers to this array causes the overall tonal balance to change. As line array loudspeakers are vertically highly directional in the high frequencies, but not nearly as much in the lows, more loudspeakers generally lead to a level increase in the mid and low frequencies only. This tonal shift closely resembles a shelving filter with increasing gain, which is why it can be compensated for by 1. The CPL or coupling control in D&B systems does exactly that. It actuates a low shelf filter that is customized to the selected system. The balance of low versus high frequencies can be adjusted in 1 dB increments from 0 to -9 dB, restoring the rough overall system balance in a quick and easy way. In both ArrayCalc and R1, this can be simulated and set with the CPL control. As SL-series line arrays provide significant low-frequency headroom, a modified approach to setting CPL has been developed to make better use of these extended output capabilities. For SL-series only, CPL now consists of 2 instead of 1 parameters, to address the mid and low-frequency ranges individually. It is now possible to reduce only the mid-range level while maintaining or even boosting the low-frequency contour. The associated filter structures have been chosen for best possible compatibility with regard to top-sub time alignment. The influence on the phase response can be observed on the alignment view in ArrayCalc.